So we learned two new terms yesterday. There was ionization, which means that you take a neutral particle and you convert it to something with a charge. So that is ionization. And then we talked about how you can reverse that process, and that is discharge. And we also talked about how both of those are redox processes, and it depends what kind of ion you're going to make. So if you're making a positive ion, then that would mean that it's losing electrons. So it is ionization is oxidation. But if it is the same positive ion becoming a neutral atom, it is discharging, then that is reduction. And we talked about that it's the opposite way for negative ions because they have to gain electrons. So ionization is reduction and discharge is oxidation. We also talked about how that relates to the reactivity. So we said that more reactive things are easier to ionize and difficult to discharge. So for metals, they're easier to become cations if they're more reactive, and non-metals are easier to become anion if they're more reactive. And the converse is true for both of them, that metals are hard to make cation if they are less reactive. And not just that, a more reactive metal will be difficult to discharge because it already has made a cation and it wants to stay that way. So when you try to discharge it, it requires a lot of energy. And for that, we use electricity. We also talked about how we use the displacement principle, that you can take a more reactive thing and displace a less reactive thing. So we talked about how we can use hydrogen to extract copper. So you take copper 2 oxide and you react it with hydrogen, it forms steam and copper metal. Similarly, you can use carbon, which is abundant, and you use that, you heat it up, it reacts with iron oxide, makes carbon dioxide and iron metal. So you can extract that. But when it comes to more reactive metals like aluminum or calcium or sodium, things are a little more difficult to do that way because they don't make financial sense if you were to use the displacement principle. Because something that is more reactive than calcium will obviously be more expensive. So it doesn't make sense to use a more expensive thing to get a less expensive thing or less valuable thing. So that is why we use electricity. So we take electricity, we break stuff up using that, and for that is called electrolysis. And what happens is that you take an ionic compound and you give it electricity. It breaks it up into the positive side and the negative side, and then those are discharged. So you take any ionic compound, you ionize it, which means that you're breaking the lattice, you melt it up so that it's a liquid, so these ions can flow. You know that if ionic compound is a solid, it will not conduct electricity because it does not have any free ions. So to have free ions, you will have to melt it. So when you melt it, it becomes electrolytes. Electrolyte is a liquid or a gas that conducts electricity. So that is what's going to happen here. We took the example of sodium chloride. So we take this electrolytic cell. This whole thing is electrolytic cell. We take anode, cathode. Anode and cathode are simply electric rods. Electric rods, we talked about that they can be of two kinds. There can be inert ones, which means that they do not react. And there can be reactive ones, which means that they do react. There are two of them that are inert. The ones made from carbon, graphite, they conduct electricity, but they don't react. And the ones made from platinum, which are which is quite a valuable metal. Carbon, unfortunately, does react at high temperature. And we saw that when we talked about aluminium's extraction. Other things which are reactive, they will also make their own ions and they will start to react during the process. So we took two basic examples yesterday. So sodium chloride separates into sodium ion and chloride ion. And then those are separated. Okay. So those are separated into sodium ion and chloride ion. And at the anode, the chloride is attracted because anode is positive and anion is negative. So it goes there, chloride goes there and forms chlorine gas. Similarly, at the cathode, sodium positive ions go and they form sodium, which is yellow liquid because the temperature is quite high. Similarly, we talked about electrolyte, aluminum oxide, which we get from bauxite, which is an ore of aluminum. So that is something that you need to remember. And because it has a very high melting point, we add cryolite as an impurity so that it reduces the melting point. The ions here are aluminum ion and oxide ion. So what happens is that the rods attract So the anode attracts the oxide and cathode attracts the aluminum ion, and they discharge both of them. So oxygen gas is made and aluminum metal is made, and electrons are transferred through the wire. And that is how you get aluminum separated from oxygen. The problem is that because the temperature is high, carbon will react. So carbon dioxide is made, and that means you have to constantly replace the anode. The anions electrode needs to be changed multiple times during the course of this process, because then you have to replace it. I also gave you these 3 examples as homework. So how many of you were able to do them, or how many were not able to do them? And if you want me to go over them, we can certainly do that. Okay, so I'll do one of them. Let's say we have iron 2 chloride, the middle one. So we have that FeCl2. So we have this setup. There's the positive and the negative. There is this battery. There's the bulb. And we have an electrolyte. So there's going to be iron ions and there's going to be chloride ions. So at the anode, what will happen is that the anion is going to go. So chlorine, the chloride ions go, convert to chlorine, and they make 2 electrons separated from them. You balance it up, you need 2 chlorides to do that. So there you go. You'll see yellow-green fumes. On the cathode side, you have iron ions which come, get electrons because they have a positive 2 charge. So to discharge, they need to gain 2 electrons, and they make iron metal. So you see a layer of this gray metal formed on the cathode. And that is how you can separate iron from chloride. Okay. All right. So that's how you complete the rest of them. Now we are going to generalize this a little bit. So far we have taken one pure thing that is in the form of ionic compound. We melt it, we put it in the electrolytic cell, and it separates into a positive thing, which is the metal, which becomes metal is extracted, and the non-metal is also extracted. What if we don't have this? What if we have multiple ions? What if we have mixtures? What if we have some cathode or anode that also starts to take part in the reaction? So for that, we have 2 principles that are our guiding principles for this. So the first rule of electrolysis is that if an anode is reactive, it will ionize. Okay. Okay, it will ionize. So that means if you have anode that is made from copper or iron or magnesium or calcium or something that is reactive, then that anode will ionize. It will form its ion. So if you have copper, you will get copper ion. If you have iron, you will get iron ion from there. So that anode is going to form its own ions. That's the first principle. What does not do this? Carbon does not do this. Platinum does not do this because they are less reactive or inert. The second guiding principle is that the less reactive or least reactive ion discharges. So when you're going to discharge them, so at the anode, at the cathode, we talked about that less reactive ions are easier to discharge. So when you're going to discharge them, then the less reactive one will discharge first and the more reactive one will discharge later. This is called preferential discharge. Okay, this whole process where one does and one does not, or waits for its turn, that is preferential discharge. So least reactive ion, the ones that are less reactive. So for example, if you have copper ion as well as iron ion, then you know that copper is less reactive. So that is the one that will discharge. That is the one that will go to the anode, and iron will not. If you have hydrogen and copper, then copper is less reactive. So copper is the one that will go to the cathode, and hydrogen ion will not. Okay. So less reactive ion is the one that is going to discharge. There's one exception though, except concentrated halide ion. What does concentrated mean? It means that it has a high number of moles. We'll get to moles later on. And what does halide mean? It means that it's from group 7. So chloride, bromide, iodide, fluoride, if you have them in concentrated form, then they are the ones that will discharge regardless of if they're less reactive or more reactive. So how do I know what is more reactive and what is less reactive? I need to know the reactivity series, which is why it's really, really important that you memorize it. All right, so these are our guiding principles. Let's try to solve some problems. So here's the thing. We have, so it's important to know what 5 things. So the first one is, what kind of electrodes do you have? Do you have inert ones or do you have reactive ones? Second is, what is the thing that you're doing the electrolysis on? So that is the electrolyte. Then is, what ions do you have? So usually this and this is given by the examiner. And then we have to figure out what ions we have, what happens at the anode, and what happens at the cathode. So these 5 things are what we need to know for any electrolysis reaction. And if you're able to do that, you're able to do any reaction that happens. All right, so let's start. Let's keep things a little simple. So we have carbon electrodes. We know that carbon will not react. Okay. Second, let's say we have sodium chloride that is aqueous, which means that it is dissolved in water and it is dilute. Okay, so we have dilute NaCl. We have NaCl dissolved in lots of water. And now we are trying to do the electrolysis of that. So that means you have this setup, this whole thing. You have cathodes and anode that is made from carbon. There is the battery. And then you have water and salt dissolved in there. Okay, so that is what you have, this electrolyte. So you have NaCl, aqueous, and this is dilute. All right, so what happens? First of all, let's figure out what ions we have. So sodium is the ion that we get from sodium chloride, and chloride is the ion that we get from that. So you have positive ion, you have negative ion. Then what about water? Now we know that water, if it is impure, so that's a very important point. If it is impure, then water will form ions. So the ions you get are H positive and OH negative. Okay. So when water is impure, it will form ions, and these are hydrogen ion and hydroxide ion. Okay, so you have sodium ion, chloride ion, hydrogen ion, hydroxide ion. You have 4 ions, 2 of them positive, 2 of them negative. Now let's see which of them is more reactive. In the positive ions, sodium is more reactive. In the negative ones, chloride is more reactive. Is this concentrated? No. So let's consider our rules. The first rule was, if an anode is reacted, it will ionize. We don't have a reactive anode. We have carbon, which is unreactive, inert. So this rule doesn't apply. The second rule is, less reactive ion discharges except if there is concentrated halogen. We don't have that. We have less reactive ion. So less reactive ion over here, H positive and OH negative. So what happens? The hydroxide ion goes and breaks down to form oxygen, water, and electrons. So this is an equation that I would suggest you just memorize at this point. There's no need to actually go through that. How does this work? So for now, I would just suggest that you memorize this equation, that you have 4 hydroxide ions. They're going to go and form oxygen gas, water molecules, 2 water molecules, in fact, and 4 electrons. Okay, at the cathode, what happens? You have hydrogen ion, which is less reactive than sodium. So hydrogen ion is going to go get electrons and make hydrogen atom. But hydrogen atom doesn't exist. Hydrogen molecule exists. So that's why we have to balance this out. You have 2 hydrogen ion, you have 2 electrons. Okay, and that is the equation. What will we see? So oxygen is colorless, so we'll see colorless bubbles. And hydrogen is also colorless, so we'll say colorless bubbles. Another word that examiner uses for these is effervescence. So effervescence is the word that we use for this, that you have these things coming out. Now, what do you have left? So let's try to make sense of this reaction. We had water. Water gave us hydrogen ion, hydroxide ion, and then those just discharged, which means that you are going to lose water. In this reaction, water is breaking down, forming hydrogen and oxygen gas. Now, here's another very interesting thing. You gave 4 electrons, and this got 2 electrons. So let me try to double everything here so that the 4 electrons are balanced. So over here, this becomes, so this thing has to be multiplied with 4 because I need 4 electrons. So that means 4 hydrogen ions come, they get 4 of these, they make 2 hydrogen molecules. Now let me try to compare this. Try to compare the amount of oxygen that you get with the amount of hydrogen that you get. Do you see those numbers 1 and 2? So those numbers are basically telling me that you will get double the hydrogen as oxygen. And why is that? That is because H2O has oxygen and hydrogen in the ratio 2 to 1. So when this reaction happens, whenever, so this is a fact that I would suggest you just note it down somewhere because it will help you in MCQs. In dilute solutions, water produces H2 and O2 in 2 to 1 ratio. So double volume of hydrogen is made and half of oxygen is compared to that. Okay. Now, another important point that we will get to in a bit, in concentrated solutions, acid breaks down. Okay. Or acid ionizes. So this is a concept that is only associated with O levels and IGCSE. Of course, you can have things that are not acid and all that, but for your exam point of view, we can see that only acid will ionize. So just remember, if you ever see 2 to 1 ratio of gas, so if you ever see that one gas is produced double as the other, then that is simply a dilute solution. Okay, so in MCQs, this will help you a lot. So if you ever see results of an electrolysis in which the gases are 2 to 1 ratio, then that means this is water breaking down, which means you have dilute solution. But if you don't see that, then that could be a concentrated solution. Okay, so that is something that I would suggest you remember. All right, so that is concentrated dilute NaCl being made up. So what happens after a while, water breaks down and you are getting less and less water left over. Now let's try to do the same thing, but this time we are going to do it with concentrated H2S, concentrated NaCl. So we still have carbon electrodes because they are unreactive, and we have electrolyte is sodium chloride, but this time it's concentrated. So concentrated sodium chloride, which is aqueous. So what ions do you have? So you have sodium ions because sodium chloride, you have chloride ions because obviously sodium chloride, and you also have water. So impure water ionizes, so it's going to give you H positive and OH negative. Now, what were the rules? The rules were if an anode is reactive, it will ionize. We don't have a reactive anode, so it will not ionize. So the first rule does not apply. Second rule said if least reactive ion discharges, except concentrated halogen ion. So in the positive ones, we have 2 of them. So which ion will discharge? Hydrogen, because it is less reactive. In the negative one, you have chloride and hydroxide. So hydroxide is less reactive, this should discharge. But then there is an exception. Do you have concentrated halogen ion? Yes, chloride. So chloride is the one that's going to discharge. So let's revisit this. The rule said less reactive ion discharges except concentrated halogen ion. You do have concentrated halogen ion, so that is the one that discharges in the negative side. But on the positive side, you have less reactive ion, which will discharge, so that is hydrogen. So what happens? You will see that at the anode, chloride goes, loses electrons, and forms chlorine atom, but chlorine atom doesn't exist. Chlorine exists as molecule. So it forms Cl2, and that is how this is made. Chlorine gas. So you see yellow, green fumes. Okay. On the other side, you have hydrogen ion that's going to go. So hydrogen takes electron, makes hydrogen atom, but that doesn't exist. Forms hydrogen molecule, doubles everything. And there you go. The electrons are balanced. So yeah, that is what we see. We see effervescence here, colorless effervescence. Why? Because hydrogen is colorless. Sure, hydrogen is explosive. So if it's coming up, you need to be very careful. Now, there's an important point to remember here. While these have gone, what is left over is sodium ion and hydroxide ion. So that means at the end of the reaction, NaOH is also made as a byproduct. Okay. And this is super important. There are three things that we're making. There's the chlorine that we're making, there's the hydrogen that we're making, and we are making NaOH. So chlorine is used for water treatment. Hydrogen is used to make margarine, and sodium hydroxide is used in so many different chemical industries. So all three products of this reaction are super important and super useful, which is why this is a very useful chemical reaction, and this is called electrolysis of brine solution. So this thing, sodium chloride concentrated, that is called brine. Okay, so this is a very useful industrial process. We have a really big setup of this in Pakistan. Can anybody guess where that setup might be? Any idea? Where do you think we would set a factory up for this? If you excuse me a bit, I need to take this call. Do you guys understand the principles of electrolysis? Now, no matter what thing you get, no matter what ionic substance you get, whether it is a mixture or whether it is a compound, just a pure compound, okay, as long as it's ionic, you can break it up using electrolysis, and that electrolysis will give you these products that you can use. Okay, so I'm going to give you an example. In fact, a question. So take 2 minutes and solve what you will do. So you need 5 headings, you have carbon electrodes, and you have concentrated HCl dissolved in water. So go on, make a table for this and write down these 5 things. What will happen? Go on. Yeah, so carbon electrode, which means it's unreactive. So first rule does not apply. All right, electrolyte, you have concentrated HCl. It's important to remember that this is concentrated. And I've told you, just a guess, that in concentrated solutions, it is the acid that breaks down, and in dilute solution, it is water that breaks down. So over here, we are going to look, I've already told you, we are going to look for acid breaking up. All right, so let's see. What ions do we have? So we have HCl is going to give us H positive and chloride negative, chloride ions. And then water is going to give you hydrogen ions, which are over here, and hydroxide ions, which are over here. All right, so that is what you get. Now, what are the less reactive ones? So you notice that I did not write hydrogen ions twice because hydrogen ions are hydrogen ions, no matter where they come from. All right, so at the positive side, we have just one ion, but at the negative side, we have a conflict. We have chloride ions and we have hydroxide ions. So if you remember a rule, the less reactive one discharges except concentrated halide. We do have concentrated halide, so that is the one that's going to go. So we are going to get chloride ions breaking down, making chlorine and electrons. So balance it up, you have 2 of them, 2 of electrons given up. And at the cathode, you're going to have hydrogen ions, which take electron. Very good, Ibrahim, very good. Just one small issue, the electron should be on the opposite side. So hydrogen gas. So there you go, we're getting these made up. What will we see? We'll see yellow-green fumes of chlorine, but we will see colorless bubbles or effervescence of hydrogen on this side. And what will happen? At the end, we will simply see that acid is being used up and water remains as it is because OH ion does not go anywhere. Okay, so that is electrolysis. And that is, in fact, the whole idea of breaking stuff up. Now, we can actually make something useful from this. And that is what we'll talk about tomorrow. Like you might have seen gold-plated stuff, like you might have seen cutlery that in luxury hotels and all those kind of places and palaces, people used to do that they would plate their cutlery or plates or I don't know, even very weird things, statues and all kinds of things. They will plate it in gold or precious metals like silver, and for many different purposes. Like some do it because it looks good, some do it because it makes it more valuable, some do it because it saves them money compared to buying a full a thing made of complete gold. It is much easier to have it just plated with gold. So we can actually harness the power of electrolysis to plate stuff with other metals. And that is what we're going to talk about tomorrow. And we'll also talk about how we can make batteries, how we can even generate electricity using this similar rules. All right, so that is the lesson for tomorrow. Make sure that you read the chapter from the book. Make sure that you solve the examples, you read the examples in the book, whichever book you're following. There are 3 books in O level, so any of them is fine. And sure, I'll see you tomorrow.